All right, so we are in Unit 6, and today we're going to be looking at for loops. So our goal by the end of this lesson, in particular lesson 2, is to be able to add writing to a game that writes three-dimensional onto the screen. In order to do so, we need to understand what are called for loops. So I'm going to walk you through basically the process of how we trace through them. You will be expected to be able to trace through and describe what a for loop is going to do. So while it may be very tempting to skip this video because you understand for loops, this does tend to be an area where students struggle just because I am very specific about how many times did that for loop run? How do you know that? What happened? And being able to trace the variables through, and this particular video has a couple of examples of how to actually trace for loops and make sure you are accurate. So to refresh your memory on the basics of for loops run the same code numerous times, and they have basically what looks like a built-in counter that we declare, initialize, and tell how to change, and this happens right in the loop. So we actually declare, and we should know ahead of time how many times that loop is going to repeat itself. That's the purpose of a for loop, is you know how many times it's going to repeat itself, and that's why that will be an expectation when you trace through your code. So just a quick reminder about how for loops are set up. Inside the parentheses of a for loop, you have three key pieces of information. This first chunk is where you declare, name, and initialize a variable. Normally that is some sort of counter of sorts. Then you have a condition, and the for loop will continue until the condition is no longer met. So it will keep checking that condition. If it is still true, it will loop again. If it is still true, it will loop again. And then lastly, it talks about how the variable changes after each time the code is run. And typically in a for loop, all three components here involve this variable that's created at the very, very beginning. So we're going to jump right in, and we're actually going to start tracing through for loops right away. So just like before when we traced with conditionals and nested conditionals, I'm going to want you to keep track of your variables. And here I see two different variables. I see score, which that's the first variable I see as I'm going through the program. So I'm going to label, okay, score. That starts off equal to 0. And then once I get to the for loop, I can see that I create a variable called count. And so I'm going to say, okay, count. That is equal to 1. And now the way that a for loop runs, remember, is that it checks the condition. So it's going to come immediately in here, and it checks the condition. And yes, when count is 1, it is less than 10. So what's going to happen is this loop is going to run, and as a result, that score gets incremented by 5. And the score gets incremented by 5 and changed from 0 to 5. And I like to add this little arrow in here to say this was the run that caused score to change. So score changed because count was equal to 1. Now we are done with the loop, so we come up here and we increment count to 2. And then we go through that process again. Okay, count is still less than 10. That is true. So this increases then by 5. Count then increases to 3. I've checked the condition. It's still true. So that means this is going to increase to 15. Then count has increased to 4. That still makes count less than 10, so this increases to 20. Count then increases to 5. That is still less than 10, so this score will increase to 25. Increases to 6, where that is still, I'm going to make that a little smaller so we can see it, still less than 10, so I increase to 30. I've then increased my count to 7. That's still less than 10, so increases to 35. Increase to 8, that's still less than 10. To 9, that is still less than 10. And then I increase to 10, and this is where you really have to be careful as you read this condition here. This will only run as long as count is less than 10. 10 less than 10 is false, and as a result we stop here. So at the very, very end of our program, what we see is that score is equal to 45 and count is equal to 10, and this is the value that essentially stops the for loop. All right, so this one you'll notice is slightly different. The counter is a little bit different. It counts down this time instead. It also goes until that counter is greater than or equal to 50. So until that is no longer true. So if we do the same thing in this one, we have two variables that we can see changing. I see damage in the first line of code, which is set to 2. And then I see counter, which is started at 100. And then remember, we immediately check this condition and say, okay, counter is greater than or equal to 50. Yes, that is true, and as a result, damage is multiplied by 2. We can see that right here. So it becomes 4. And then this is telling us that we subtract 10 every time. So this now becomes 90. 90 is still greater than or equal to 50. So we multiply this by 2, and that becomes 8. We then subtract 10 more. 80 is still greater than or equal to 50. So we multiply it by 2. And then we know that we're going to subtract 10. So we're at 70. 70 is still greater than or equal to 50. So we multiply by 2. Subtract 10 at 60. 60 is greater than or equal to 50. 64. We then decrease by 10 more, and this is still true. It is still greater than or equal to 50. So we multiply by 2, get 128. And then here, when we finally hit 40, this is the number that stops the for loop, because that is the first thing that is not true. It's the first thing that won't work in that inequality. So to end this, we have damage that is now set to 128, and our counter, which is now set to 40. All right, so with this problem in front of you, what I would suggest is trying it on your own first, and then seeing if you did in fact trace through it correctly. Okay, so I'm going to trace through this as well. You can see that we have lives, which starts at 9. So I have lives starting at 9, and then I go into my for loop and I see that I have a counter that is starting at 7. And I know 7 is in fact greater than 3. I know that is true. And so I see that lives subtracts 1. And then from here, my counter subtracts 1, so I'm at 6. 6 is still greater than 3, so I subtract 1. Then my counter subtracts 1, so I'm at 5. 5 is still greater than 3, so we subtract 1 from lives, subtract 1 from counters. Counter is still greater than 3, so this decreases down to 5. Subtract 1 from counter, and this right here, counter is not greater than 3. 3 is greater than 3 is false. So this is where our for loop stops. And as a result, we know that lives ends at 5, and our counter ends at 3. All right, so on this final slide, I'm asking you to practice actually writing a program to do the following. So this is going to take a little bit more work because you have to purposefully think through how this is going to run. So the first thing, it says prior to the for loop, initialize a variable called score that is set to 0 to start. So I'm going to create an integer called score that is set to 0 to start. Then from here, I know I'm going to have a for loop. So I know I'm going to have a for loop, and it's going to have 3 different conditions inside of it. So I have space for 1, space for 2, space for 3. And then from here, I know that inside my for loop each time, I want it to add 10 to score. So score inside of the for loop is going to equal score plus 10. Now the tricky part here is actually figuring out what goes into these 3 areas. So first thing that we need to decide is what this variable is going to be named and initialized to. So I'm saying I'm creating an integer, and maybe I'm going to name it count. And normally I just set these off being equal to 0, so that makes the math a little bit easier. So I have a for loop, I have a counter that it's set to called count, set to 0. And then the next part here is that I want it to run 5 times. So normally the easiest thing to do in your for loop is to just have the counter be counter plus plus and add 1 each time. That's normally the easiest thing to do. And then from here we need to think through, well, this is going to start at 0. And if I add 1, that's going to run. I need that to run, I need that to run, and I need that to run. So really, these 5 numbers right here, if I'm only incrementing by 1 each time, make it run 5 times. So I need a situation where these are true, and then it will stop once it reaches a particular number. And there's actually 2 options that you could put on that blue line. The first is you could put that you want this to run while count is less than 5. And it will run during these 5 cases here, but then will stop when you get to 5. Your other option is you could write count is less than or equal to 4. Again, it will continue to run while the counter is less than or equal to 4. So it will run when it hits 4, but when you hit 5, it will stop. So once you're getting to this part right here, what I would do is off to the side, kind of like I did, just write down the numbers that you need to work so that it runs the set number of times. And then decide where it would stop and pick a condition where that would be the first number where it would stop. So at this point, you are done with all the videos for lesson 2, and you can move on to the worksheet for the for loop.